In this lesson, you will identify and generate geometric sequences and relate geometric sequences to exponential functions. So first of all, a geometric sequence is a sequence in which each term after the non-zero first term is found by multiplying the previous term by a constant called the common ratio r. So the letter r is going to represent our common ratio. R cannot equal 0 or 1. It can be a decimal or a fraction, or it can be a whole number. The common ratio is the number by which each term in a geometric sequence is multiplied. So the first example you're going to have is to look at a sequence of numbers and identify, is it geometric or not? If yes, you will say what r is. If not, you just say no and move on. So let's start with this sequence, 256, 128, 64, 32. What you have to decide is, how am I getting from each term to the previous? So we can use division to see what our common ratio is. And when I divide 256 divided by 128, I get 2. So in not multiplying by 2 here, I'm dividing by 2. And if you'll look, if I'm dividing by 2, that means I'm taking half of each term. So this is a yes, and my common ratio r is 1/2. If I multiply 256 by a half, I would get 128, so on and so forth. If you wanted to write this as 0.5, you could do that as well. How about this sequence? I take 9 divided by 4, I get 2.25. When I do 12 divided by 9, I get 1.3 repeating. That is not the same quotient, so I do not have a common ratio here. So this is going to be a no. Just say no and move on. You only have to write the r when it's geometric. The next example is to find the next 3 terms in each geometric sequence. So the first thing you have to do is find out what r is. I'm going to divide, so -4 divided by 1 is -4. 16 divided by -4 is -4. So my common ratio here is -4. So I'm just going to multiply each term by -4. So -64 times -4 is 256. I multiply 256 times -4. I get -1024. Oops, 1024. And the last term would be -1024 times -4, which is 4096. So as you can see, I've found the next 3 terms in the sequence, and I'm done. I move on. So let's try B. This one's a little different because I can't just look and obviously see what my next term would be by multiplication. So I'm going to take 36 divided by 24, and I get 1.5. So I'm going to go ahead just to see, if I take 36 times 1.5, do I get 54? And yes, I do. So I know that my common ratio is 1.5. So I'm going to take 81 times 1.5, and that would give me 121.5. I take 121.5 times 1.5, and I get 182.25. And my last term then, times 1.25, would be 273.375. So you're using your common ratio to find your next 3 terms. Try the examples in your notes. Now there is a formula for a geometric sequence, and I want to try to help you find it. So this stands for the position of the term, wherever it is located. And so this is first position, second position, third position, fourth position, so on. Now if you'll notice, this is 2, and that's going to be our first term. So the symbol we're going to use for first term is a sub 1. Now this term is 6, which is that a sub 1 times 3, because 2 times 3 is 6. This next term is a sub 1 times 2 times 3, or 2 groups of 3, because I had times 3 times 3. So that would be 2, in this case, your first term. Another way to write this maybe would be, you have this a sub 1 times 3 times another 3. So let's just write that as 3 squared. Would that be okay if we do it that way? Write it as 3 squared times that first term. So if you look, this could be 3 to the power of 1. So can you think about what this would be if we use that same power situation? The a sub 1 would still be there. Now this would have to be 3 to the, well, what's up next here? Third. So 3 cubed, which would be 27 times 2, that would be giving you your 54 as well. So this is where the equation comes from. It's taking your position where you're located. So as you can see, this is the first position. The second position gets a 3 to the 1. The third position gets a 3 to the 2. This is a lot like that penny problem that we did, how many pennies, how you're going to figure out whatever the term is, what that power would be. And so what we are going to do then, I'm going to give you the formula and I want you to be able to see where it comes from. A sub n is going to refer to any value in this equation. N is going to be the position of the term, so this is what we call n here, is going to be equal to a sub 1, and remember a sub 1 is going to be the first term, whatever's first in line. So a sub 1 times r, so I'm going to put a dot for times, r, and that's the common ratio. In this case the r was equal to 3, right? Times 3 times 3 times 3. R to the power of n minus 1. Now you can see from this example where this comes from. Our common ratio is going to be to the power of the term that we're looking for minus 1. And you can use this formula to find any term in a geometric sequence. So what's that formula again? A sub n is equal to a sub 1 times r to the power of n minus 1. Another way that you could write this, you don't have to put that dot in between if you don't want to. So if we were to write an equation for the nth term of the sequence, what we need to do is figure out, okay, what is everything in there? N is going to stay n because I'm looking for the nth term in a sequence. The a sub 1 is going to be the first term, and if you look, the first term here is negative 6. The r is going to be the common ratio. Now I'm going to have to find that. So I'm going to take 12 divided by negative 6, I get negative 2. When I take 12 times negative 2, I get negative 24. So this is going to be a negative 2 for r. Now that I have all the values that I need, I can write it in the equation form. So a sub n, because I'm leaving the n as n, is times, negative 6 times negative 2 to the power of n minus 1. This is what the equation would look like if I'm leaving n as n. And then what I'm going to do is see if I can't simplify. Remember, I'm going to keep these separate because this is a whole power that you have to do first before you multiply. So you can't simplify this at all. This is how it stays. And I know that might bother some of you because you're going to think we can multiply these two, but we can't because you have to apply this power before you can multiply here. If we want to find the ninth term of the sequence, we would do a sub 9 is equal to negative 6 times negative 2 to the 9 minus 1. So we start by subtracting, and we have negative 6 times negative 2 to the 8th. To type in a negative 2 to the power of 8, you have to use the parentheses. So I do parenthesis, negative 2, parenthesis, to the power of 8, and I get 256. I multiply that times the negative 6, and I get the ninth term, a sub 9, to be negative 1,536. So instead of having to just keep going until you get to the ninth term, you can actually use the formula to find that ninth term. So try the example in your notes. What's going on?